and today I'm going to be explaining my code. Now, we were tasked with making a shell emulator program for our Professor Ebbets class, and basically what it's supposed to do is it's supposed to emulate the Linux shell. Now, you could do it in a couple of things. You could do it in the online virtual machine. I chose to do mine in Ubuntu. However, I had a lot of problems with Ubuntu this time and this year. It's just because of my own incompetence, but nevertheless. So in my program, I didn't start off with int main, but int main is where all of the beef of the program is. So we started off with 3 variables: char, buffer, 100, with a field of 100, PID T, PID, and int status. Now, the buffer, which has the field of 100, is basically so the program will be able to have a field to save commands. Process ID is, for example, if the user enters ls, it'll have a PID of 1000, and then when it forks, like the program has to do, the child, the program will have a PID of 1001. So printf, all that does is just, it basically displays the like this symbol right here. It basically displays that. So home, it'll be home, and then you'll type in whatever command, but into the loop, the while loop. So it's basically saying, okay, F gets the command and puts it into the buffer. Whatever the size of the buffer is, it puts it in there, stores it in there, and it takes null as the final argument. So this if statement, it checks if the character has a new line towards the end, and then it replaces it with null or 0. So if I enter change directory will have a new line character at the end, but this will basically make that null to make it 0. So it'll just be the command. And then finally we get into PID and fork. Oh jeez. And basically what fork does, fork allows us to make run two processes at the same time. And those two processes will be the father and the child. We went over fork in class, and basically fork is just a useful tool for when you need to accomplish multiple things at the same time. The parent and the child will be related whenever you fork something. So for example, if the parent has a PID of say 1000, the child's PID will be 1001. And that's their relationship. For they'll both be it'll be the same, however they'll be in different places in memory. So if I wanted to say here, hello, I am your father, and I wanted to say in the fork process, hi, I am the child, while they're both saying something, they both have a command executed, they'll both be in different places in the memory. So if PID is less than 0, PID is less than 0, then it'll prompt the user to run the executable, to run the next command. And then we got else if PID is equal to 0. This is where we have our executes. And so here it'll say it's buff. It takes the buffer as a parameter and char 0. And It basically tells the process to wait. Wait for the change of state in the process. For instance, if the child is forced to stop by any signal or any other change of state, this would basically cause it to wait until that process is over. Wait basically allows us to allow one process to finish its purpose before we move to another one. And then finally the program printf home again. And so from here it goes back to the beginning, and then it just allows the user to do whatever command they want it to again. So in all together, the program would, for instance, we ran ls, list command directory. It'd run through this code, list the directory,